Hello, it's me, Philip, and this is a Karcher WV2. Now, I've looked at this in the past because it had a stuck motor, which I unstuck and got it working. But somebody has commented on one of my videos, Catherine here, has said I have the same issue, but the green light should definitely go off. It should only illuminate when operational. Now, I've had a quick Google of why the light stays on. It's inconclusive. As you can see, the light is on. When I press the button, it lights up more, but there's always a faint light. If I plug the charger in, it flashes until it's charged up, and then it stays on full brightness. But when I unplug the charger, the light always stays on. It's been 4 months since I fixed this, and the light is still on. So I'm going to open this up and see if I can find out what's going on with it. And to open this up, I'm going to use a T9 torx screwdriver. Okay, so there's the light. We're going to remove most of this. I wonder if it's just a little bit of corrosion on the board. Or could it be something up on this end? Normally you would disconnect any batteries, but these are going to be a pain. I think I've got some IPA. I think I'll clean it up first. See if that light goes off. Nope. I think I will take this motor off from here just to make it a little bit easier. Before I do that, I'm going to measure the voltage on here. Right, 4 volts. I've got 1.5 volts on there. I'll pull this off here. It's glued on, so I cannot see what's happening underneath there. So I've got some corrosion up here. There's a little bit of corrosion on that capacitor. I don't want to poke around the board too much with the battery in. I think the best thing to do is to take this battery out, take the motor off, and then give the board a good clean. And then I can connect my power supply to the battery contacts and power it using my bench power supply for testing. We'll do that. While my soldering iron is heating up, I will clean that little bit of corrosion there. Now the light's still on. I'm kind of assuming it's getting 1.5 volts. And when the power comes on, is that the 4 volts? I don't know. I don't think you can open this piece. Right, let's see if we can get this battery contact taken off. The positive is very corroded. There we go. I think what I'm going to do is I'm going to have to peel this off, connect up the bench power supply and find out which lead does what, and find out what voltages I've got on the cables when I press the button and when I don't press the button. I could do it from the back, but I won't know which components to go to. Try some IPA to melt this glue. So I've scraped away a lot of the glue. That glue, it doesn't look like it's been protecting the wires very good at all. That looks like a lot of corrosion. This resistor looks like it's lost some of its top surface. I think I've just scraped down there on that one. So what I'll do is I'll pop a little wire on here and a little wire on this side, and we'll power this on with the bench power supply and see what happens. Okay, so the battery is 3.7 volts. So I've hooked my power supply up to the battery terminals, and I've got 3.7 volts on the power supply. So we'll switch that on, and now we'll have the little green light. As you can see, it stays on. So what's my next step? So the power supply is switched off. I'm on continuity. I've got a capacitor here, just out of sight, so that's ground. So none of these are ground. I'm just looking to see if I've got a short on any of the... Just checking for shorts. So the purple cable comes to this resistor and then to ground. The resistor is 0.8 kilo ohms. This one's 0.8 kilo ohms. 451 ohms. Now that could be 821, which is the same as that one, which read the same on the multimeter. Those cables look terrible. I don't think it would cause the fault. this one comes down to this resistor, which also looks like it goes to ground. Right, positive on the battery terminal, comes to here. It does go through the diode, but it comes up here through this resistor to here. So this little resistor measures 47 ohms, and that goes to this middle lead. Where does this one go to? That might just go to this. Does that go to there? I think it just pops to here. Yes, it does. That could be anything. Resistance 57 ohms. That looks like a 3 on the end, or it could be another 5. So if I label these wires up 1, 2 and 3, between 2 and 3 I get 1.3 kilo ohms. If I press the button, it drops down to 0. So that's the switch. So they are switched. So hold on. If there's an LED in there, I should read a diode one way, shouldn't I? So did I say 3 went to power? I'm sure 3 goes to the 3.7 volts. So can I read a diode between these pins? 2.1 between 1 and 2. And am I going to get open? No. 2.1, 1.6, 1.7 and open. 1.7 and open. If I was testing a diode, would my green light have come on? No. Perhaps there's not enough voltage in the multimeter. It's a shame I can't get this open, but I don't want to fiddle with it. So the bottom 2 pins are the switch, from what I can work out. And the top pin goes to a 56 ohm resistor, and then to a component labelled WH61. So I'm assuming that's some kind of transistor switch. So I'm thinking this is more complicated than just a switch and an LED. But I don't want to break it by opening it up. It might actually come apart easier than I thought. Ah, look. Hold on. That was the other way around. That was twisted. That was definitely on that way, but it's twisted. Right, what's in here? It's not more complicated, it's just a blooming switch. Some corrosion. It's got a switch and a diode. Could the switch be full of gunk? That cannot be it, surely. That cannot be the problem. I wouldn't have thought so. Right, let's see if I can test that diode with my multimeter. 1.6. Swap the leads. And 2. We said this one was ground. The middle one goes to power. And it looks like this one's for the LED. 1.36 kilo ohms. Drops to 0. This is the button. 1, 2 and 3. Now I've got 1.1 volts on the LED, which is causing it to light up all the time, even when the button's not pressed. Is the corrosion inside the button, because even with the button off, I'm getting 1.1 volts between 1 and 3, but the button looks quite easy to pry open. Well, that looks clean as a whistle. There couldn't be anything underneath the button, I suppose. 1.36 kilo ohms. Surely it should be open circuit. So there could be something underneath the button, or there's a problem with the circuit. So with that out of circuit, let's test it again. Now it's open. So it's not a problem with the button. The button's fine. It's a problem with the circuit. So here's the power switch. So it's actually switched off at the moment, but I do have some voltage creeping through this LED. So I've got 3.6 to the switch, and that runs through here to this LED. And then the LED, the negative of the LED, runs out down this, we'll call this wire 1. So I've got 1.1 volts coming out of the LED. So I'm assuming if I've got 3.6 here, the LED's taking 2.5 volts. But it's regardless of whether the switch is on or off. It's off at the moment. If I press the switch on, the LED lights up. If I switch it off, the LED dims. But I've got 1.1 volts coming out of it. And it goes down to this wire 1, which comes, it's this top wire here, through this small resistor, comes out of the resistor to this wire. Now the wire is this one, and that doesn't actually go anywhere. So we've got 1.1 comes up to here, but then it doesn't seem to go anywhere. This is ground, and this pin comes all the way down to pin 8 on this microcontroller, which I believe, if I can bring this up, that's this one. So this is an 8-bit microcontroller, and pin 8, now I think that's a TXD1 transmit pin as far as I'm aware of. So I'm assuming this transmit pin sends a signal to this transistor to switch on. It could be this chip could be faulty, or this could be faulty. I'd expect there's a couple of diodes in here. I'll check that. So we'll go to diode mode, 1.2, swap the leads, 2.1, 1.7 and 2.3. So I think that's okay. So I'm wondering if this chip is faulty. What I think I'll do is I'm going to lift pin 8 on this microcontroller and interrupt the signal from the controller to the transistor here and see if the LED stays off. If the LED stays on, it could be the transistor. I'm calling it a transistor. I don't know whether it is a transistor or not. I'm expecting it is. Yeah, so that's lifted up okay. So with pin 8 lifted up, which may or may not be supplying a signal to this transistor, which may or may not be a transistor, we'll switch it on and it still lights up. Interestingly, it doesn't change. I don't know if that's full brightness or half brightness now. I'll switch off. I wonder if I can bridge that lifted pin back to the pad. Let's try that again. Right. So there's half brightness and full brightness. If I take this short away to the pad, we're still on half brightness. So it appears pin 8 tells the system to switch on, or part of the system to switch on. There's a difference in state with the pin lifted and the pin down. So the controller, or certainly the part of the controller that controls pin 8 might be okay. Let's get pin 8 put back down. So with that back down, so the problem must be this, surely. If this was on fully, the LED lights up fully, but that must be leaking something through there. Assuming if I bridge that pin to there, to ground, that's what happens when pin 8 switches this on through this section here. So if I bridge that to there, will my LED light up full brightness, or will I damage something? Right, pop that there, and we'll bridge those two pins. Yeah. So that's pin 8 turning that on. Must be. So that must have a problem with it. Let's see if we can figure out what it is. So this is a WHS61, and I've had some help. So I popped over to Learn Electronics Repair Discord channel, and a gentleman, I think it's a gentleman, by the name of Harox has took me through a few steps to try to work out what it actually is, and we came to the conclusion it's, from the name on the chip, it appears to be BCR108, which has got the marking WHS, and it's a SOT23, and I think it's just leaking current when it shouldn't be. So I've ordered some more, and these are them. So I'm going to swap that over, and hopefully it'll solve the problem of the green light stopping on. Right, so that's got to go onto there. I don't know whether to take this cable out or just try to get in with my soldering iron. I don't want to use hot air. I'll melt this cable, won't I? And perhaps this plastic. I'll put a small tip on my soldering iron. Hang on, I think that's it. I think I'm caught on some glue. There we go. Here's the new one. Brilliant. I'll put a little bit of extra solder on. That'll do. I'm going to be at a loss if this doesn't work. If this does work, I'll put some blue solder mask around the base of these wires to keep them in place where I scraped the glue from. this does seem to be an uncommon fault. We'll hook these up to 3.7 volts and we'll switch on. And the light has stopped off, but is it going to switch on when I press this button? Oh, it is. It's nice and bright. So on and off. Right. So now all I have to do, I've got to reinstate the battery and put the charger in and see if it'll charge the battery, and when the battery charges it should flash. So that's what I'm going to do next. Right, that's the two battery terminals soldered up. I'm going to clean them up and I'm going to put a little bit of silicone grease on the ends here just to try and keep the water off it. Right, I think we should test it first with the battery in. Power on, power off. Brilliant. Where's my charger? Plug that in there. Switch on. Hopefully we'll get a flashing light. And we do. So hopefully when I turn this charger off, the light will go out. And it does. Excellent. I've got some solder mask on there, and I'm just trying to look at the old video and work out which way this motor goes. And I keep forgetting that the battery's charged up. So I've got to be careful not to short something out. I think that's it. Right, so that should spin now. Switch on. Brilliant. Right, I've got to get it back in here. I think that's all the soldering done. Oh, I was going to put something on these battery terminals. I'm going to use some silicone grease. Right, here's the tricky bit. There's a fan to go on top of there. I'm just testing it every step of the way because I think these get dropped and then the fan blade moves and fouls on the inside of here, which I think is a common occurrence. Got to put this strange shaped piece on. See, that fan blade, I'm getting a flashing light because that fan blade is fouling the inside of here. So I've pressed it down a little bit further. We'll try it again. Right. So there you go, I've just proved my point. I'm sure this bottom piece was twisted. Right, I think that's it. That's it. Right. So that goes around there, up there, and in there. It's twisted for some reason. That goes in there. That should hopefully go in there, and it does. Don't think I've left anything out. And the light stops off. Fantastic. And I need a T9 if I remember rightly. 6 screws. 1, 2, 3, 4, 5, 6. That's not the right one. That's the right one. I have really enjoyed this fix. We can clip that back into place. Pop that back on. I've got the top here. And that's it. Job done. So, I've really enjoyed that. I'm going to shout out to Catherine here, who put me onto making this video. Thank you for leaving me a nice comment on my previous video and inspiring me to do another one. And I'd also like to thank Harrox from Learning Electronics Repair, who confirmed my suspicions I wasn't sure whether or not a transistor could leak current, so I felt a bit nervous about seeing what I thought was happening, but it does look like I was right. This is the problem with learning electronic repair. The hardest thing is finding the things to repair that just push your knowledge a little bit further. If the problem's too difficult, you get disheartened. If it's too easy, you don't learn anything. And that's exactly why I've enjoyed this problem. I've enjoyed it because it's just been the right amount of challenge to be challenging and enjoyable without making us feel like an idiot. So I hope you've enjoyed that video. It's a bit of a rare occurrence, I think, with these Karchers. Most of the time it is just a stuck motor or a stuck fan blade, but this one's a little bit different, and it was well worth opening it back up and taking another look at it. So thanks very much for watching, and I hope to see you all in the next one.